Hello. So my name is Brenna Buuck. I'm a developer evangelist at MinIO. Before that, I was a data engineer for a long time.
I'm Karthik, software engineer at MinIO.
Great. And we're here to talk about what it takes to make Iceberg work for AI. Specifically, we're going to look at the role of the catalog and how different deployment choices can shape scalability, governance, performance. And then we'll share how and what we learned from embedding the Iceberg catalog directly into object storage as one possible approach. So we're going to cover 4 things. We're going to talk about why AI workloads demand unified access across all enterprise data. We're going to talk about the security and cost realities of an on-prem deployment of Iceberg versus a cloud deployment. And we're going to talk about the lessons learned from us embedding the catalog, the Iceberg REST catalog inside MinIO. And finally, we'll do a hands-on walkthrough to show how this works in practice. So our starting point is simple. AI can only learn from the data that it can reach, and fragmentation is the main barrier. So enterprises hold petabytes to exabytes of structured and unstructured data, but historically it's been siloed across different systems and formats. This is not a new story for all of you guys here because your Iceberg practitioners are interested in becoming Iceberg practitioners, so you know that there was a time in the past where the only option was structured data in a database or a data warehouse and unstructured data in a data lake. Iceberg has solved this problem. It's emerged as the de facto format to unify these different types of data with an incredible, massive adoption. So this is my love letter to Iceberg. I'm sure we can all support this one. But the open question has really remained, how do we extend that unification property to all of our data so that AI agents can reason across everything? And one of the ways that can be done is through this strategy. So, AI agents has to traverse over all of your data, and not all of it is in neat tables. So you've got things like documents and images, videos, and logs. They'll live in buckets in object storage. And for AI agents to actually use that data, it needs to be discoverable in the same way that structured data is. So that's where an Iceberg catalog can unify both. And this is one strategy to make that work. So if you have a catalog embedded in your object storage, you have the possibility of having 2 different types. Well, they're all objects, really, but you have 2 different types of data in your object store. Your raw buckets, your raw object buckets, where you have things like unstructured files, PDFs, images, training videos, all that stuff. And instead of leaving them untraversable by AI, you could insert pointers to their location inside your Iceberg tables. In this example, so you have a table stores an asset ID, an asset type, the object path, the full S3 object path, and then maybe tags. And that structured metadata effectively maps to all of your data, all of your objects, whether it's structured or unstructured. So it does 2 things. It unifies discovery, so both AI agents and humans can query the table like any other Iceberg table, but instead of hunting through a repository of data, like a random bucket, you can get the query, the metadata, and then get back the pointers to that location. So you can find everything that you need. You have seamless traversal across all of your data. So I think of this as just extending Iceberg role. This is just a pattern of behavior that you can do when you have both of your data. You have tables and objects inside the same platform, is that you think of extending Iceberg role. So it's not just managing schema evolution or table lineage, becomes very much a part of your entire enterprise data strategy. So I want to just look at some deployment realities. So, there's always be a place for the cloud. That's a reality as well. They offer flexibility, scalability, But they also introduce challenges around cost and compliance, which I'm sure we're all familiar with. It's somewhat of a rite of passage to get a really scary cloud bill at some point in your career. So an on-prem Iceberg deployment can address some of these. So I'm just going to do this one really briefly because you're all Iceberg connoisseurs, so that you already know that Iceberg relies on a catalog. It's what makes tables discoverable. It enables schema evolution. It lets multiple engines work consistently. In a meetup like this, I don't need to convince you why catalogs are essential or even that they exist. But what's worth exploring is how catalogs can be deployed, because that's a huge implications for governance, scale, AI, and that's what we're focusing on today. So at petabyte scale, the cloud introduces two categories of problems that really matter directly for Iceberg deployments. The first is cost unpredictability. Remember those unpredictable cloud bills? The real costs come from egress fees, but also API fees. So let's say you have large volumes of small objects or small files, small tables, and in the cloud, those I/O patterns really amplify across especially hot data. You get charged for every get and put every time you access that data. And it's not that obvious at around 100, but at around 100 terabytes, it becomes a significant problem, okay? So small data, a small amount of small data is not a problem. A large amount of small data can be a problem from a cost perspective. There's also things like cross-region and multi-cloud replication, which you need for data durability and resilience, but also multiplies this cost again. So if you've replicated your data, then you've increased your cost every time you transact over that data. There's also compliance gaps. So some of the highest value data sets, things like financial records, healthcare data, customer PI, they're bound by regulations that prohibit storage outside specific jurisdictions. So I live in Vegas, and there is compliance regulations about gambling data that has to stay in the States. This is a prime example of a type of data that has to stay within a geographic location, or a actual physical has to be at the casino, right? So, and even if encryption is in place, which it should be in every public deployment of Iceberg, the cloud provider does control the physical infrastructure and access paths, and that can be problematic, especially in these like the regulated environments that I just did. And this is not, in terms of Iceberg, this isn't just about where the data sits, it's also where the catalog lives, where it operates. So a cloud-managed catalog, can be disqualified for workloads that require sovereign infrastructure. So if you've got a cloud-hosted catalog, it can be a problem for some. And that's why just to say that if you're planning an Iceberg as the foundation for your AI workloads or any kind of analytical workloads, you can't treat cost and compliance as afterthoughts. You have to think about those implications as you're developing your service. So, and this is just another exploration of that concept. For the most sensitive deployments, air-gapped architectures are the most secure. The idea is really simple. You can cut the network paths, you can remove the cloud control planes, you can enforce zero trust by design, and there's layers to this security which you can peel back as your workloads or requirements demands. Start with physical isolation, no network or outbound, no inbound or outbound network routes. You can go into encryption. With AIStor, data is encrypted at rest and in motion. There's namespace level IAM with role-based access control, which Karthic will go into. You can also rely on object storage. All Iceberg deployments are built on object storage, so you can rely on object storage's inherent immutability. A worm, right, once read many locks prevent data tampering. Things like audit logging and compliance hooks. So, every catalog operation can and probably should be logged so that you have a compliance or audit trail when you're asked for. And you're probably asking yourself, if you're in a low compliance environment, why does this matter? If you're building AI systems in healthcare or in defense or in a casino, regulators won't accept the cloud is secure as a reason why you've chosen to build your entire infrastructure in the cloud. So this is a pathway to full compliance if your workload demands it. So we talked about control, data sovereignty. Let's talk about cost. So that's the other side of that coin that we discussed. This is a case study modeling a very hot data lakehouse cost at scale. So at a few hundred terabytes, the cloud and on-prem look roughly comparable, but around 5 petabytes or 5,000 terabytes, there's a clear inflection point. And I have 3 petabytes on my laptop. So you can see 5 is here, where you see the inflection point start to go up and the differentiation start to become really clear. And from there, the economics are really no contest. On-prem is consistently cheaper, and the gap only widens as you scale. So we see customers who have saved like 60% of their cloud costs, their operating cloud costs for their data lakehouses when they migrate on-prem. We're talking about super hot data. Cold storage will always be cheaper on the cloud. But if you're transacting over your data, over 5 petabytes, it will be cheaper to move on-prem. So there you go. And if the other element to this layering is that if you need performance in the cloud, that means moving to S3 Express or Azure Premium Blob, and those also come at a premium, right? And so if you want to go fast and if you want to go a lot, it'll be cheaper to run on-prem. So with that, I'm going to hand it off to Karthik, who will talk about the lessons we learned from embedding the Iceberg catalog REST API inside object storage.
Yeah, thanks, Brenna. Firstly, I'm glad there's not a session right after lunch, so everyone seems to be still listening. We just launched AIStor tables yesterday, basically natively embedding the Iceberg catalog APIs alongside the S3 APIs in every instance of MinIO node, right? So now, Brenna made a case for how your Iceberg tables inherit the underlying capabilities of the object storage. For example, it could be encryption, it could be the lifecycle management, it could be the replication, right? So every Iceberg table naturally inherits the capability of its underlying object storage. But while this enables you to seamlessly scale, keep your data secure, or have so much of features that applies to your data, doesn't necessarily apply to your catalog, because most of the catalogs are based on Postgres. So here's our learning, and here is why we decided, and maybe our customers who are running Iceberg tables at scale almost forced us to make this happen. So yeah, now, the first, here are the advantages of breaking, catalog right into the object storage. But before we go there, I think Kevin also in the previous talk made it clear what catalog brings, into your Iceberg tables. So even today, even without natively having the Iceberg catalog embedded right inside your object storage, you're still using Iceberg tables, right? You have your catalog outside, and you have all the data, which lives inside the object storage. Of course, these are the typical values that catalog in general brings, if you are new to what Iceberg catalog does. So basically, in object storage, you operate on an object level, which means the object storage is object-oriented, but the Iceberg is table-oriented, right? So this language, being a table-oriented language, is not what object storage natively understands. What does that translates to? For instance, Inside object storage, let's say you have a bunch of set of Parquet files which belongs to your table. You have to explicitly mention that, hey, here are the set of Parquet files or this path inside my object storage, and I want to apply certain security policies, or this is how I want to manage replication. Everything inside an object storage is object-oriented. It does not understand that object storage natively thinks each object is on its own. They don't understand that bunch of objects we belong to a family of table, and there is like a logical grouping or an entity that we belong to. They have absolutely no awareness of it. So one of the advantages that the native integration brings is it makes our object storage, which is object-oriented, to now being table-oriented. What does that mean? So for instance, like if you replicate objects in an object storage, and which natively MinIO and S3 others provide, if the system is not table-aware, potentially it might cause inconsistencies in your table. I mean, look at an example of replicating an Iceberg table. If you move the metadata first to your different replication setup, and a query engine will look at the metadata, and it will think, now I've got this million Parquet files, but the Parquet files are still being replicated, right? This is just one classical example of when an object storage is natively not table-aware, it actually transfers the burden of managing it right on to you. And here are some of the design considerations that we naturally inherited from the object storage while baking in the catalog, right? Like, for instance, like the high availability, right? MinIO AIStor, we have customers who are running at an exabyte scale with few thousand deployments right now. In each instance of MinIO, along with the S3 APIs, you also now get the Iceberg catalog APIs. So what does that translate to? So naturally, your catalog APIs are highly available now. You do like a 100-node deployment of MinIO, each one of the node also comes shipped with your Iceberg catalog APIs, which means you can create your tables, commit the transaction, do a multi-table transaction by you routing your request to any one of the deployed MinIO nodes. So it's naturally by default highly available, and which is the underlying property of the object storage, which the catalog now directly inherits, right? And operational simplicity, right? You don't necessarily have to manage another database in production. So one of the reasons why we were forced to build this is we've been bringing a lot of enterprises who are managing data over a few hundreds of petabytes at scale to Iceberg. And this is something common that we heard across these customers is that, hey, we would love to move to Iceberg, but can you manage Postgres for us inside your private data cloud? And we had to say like, hey, that's something that you should do it yourself. And they were like, no, inside private cloud, it's a mess for us. It's a lot of operational burden for us to manage our Postgres, to take a backup, to make it highly available. You get it for granted for free with managed Postgres services on AWS or on Google Cloud. But when you're on-prem, when you're inside your own data center, the operational burden is on you. So it could be governance now, it could be the performance characteristics. So all of the underlying advantages what MinIO AIStor offers is directly inherited by the catalog. So even half the number of your catalog nodes or the MinIO nodes can go down, your catalog will still be highly available and is resilient. It can recover your transactions. So naturally inherits the scalable property which the underlying object storage offers. Now, the next immediate question that you might ask is that, hey, would it be really fast? Like if it's built on top of object storage, isn't object storage supposed to be slow for transactional style workloads? Because ultimately what Postgres does in our Iceberg catalog is helps me commit my transaction. So isn't that supposed to be like backed by a transactional store, which is which should be able to perform these transactions very fast, like the RDMM style or like a transactional database style? The answer is one great thing about the transactional or a concurrency model of Iceberg transaction is that it follows an optimistic concurrency model. which means by design, you'll not be bottlenecked by the performance of the underlying database that you use for your catalog. Your actual performance bottleneck by design comes from Iceberg's concurrency, transactional model. So the concurrency transactional model or optimistic concurrency model is not designed from ground up for you to perform thousands of concurrent transactions. It will all conflict out. Only one of them can succeed. The rest of the concurrent commits will actually fail and conflict out. You have to retry from the client. So that's how Iceberg is designed. It's not designed. Big data transactions is very different from data transaction. They're not the same. So hence, you actually do not need a super highly performant transactional store which can close hundreds of thousands of transactions in a second. That is not how Iceberg transactions are fundamentally designed. Even if you have a world's fastest database, you'll still be bottlenecked and choked by the optimistic concurrency model which Iceberg is designed. Yeah, so here are some specifics of how you're going to use, AIStor tables. Here are some of the examples, of how you set the security model. How you operate it. It's all inherits the existing functionality of the object storage. For example, your similar S3 policy is what you use for data. Now we can extend the same even to secure your catalog APIs. No new mental model at all. Of course, now, since the Iceberg catalog, is most of the engines are catalog compatible, you can try your favorite engines. It could be Trino, it could be Dremio, it could be whatever, Spark. Bring any of your favorite query engines on top without having to manage in catalog. And also, as a lot of great warriors say, you are as strong as your weakest link. So we have heard from our customers, right? Postgres has actually become a bottleneck for their big data pipeline, because now if your catalog goes down, then you cannot commit any data into your object storage, and the rest of the pipeline that now depends on bringing data into your Iceberg tables. It could be a streaming pipeline. It could be your query engines. The entire failure across your big data system will cascade into a wildfire, and it's going to bring your entire big data system down. So you can say, I've got everything else that scales well, that performs well, but again, as great warriors said, you're only as strong as your weakest link. Okay, that's it for our talk. Thank you for your time and interest listening to us. And also, we today, in collaboration with the amazing Alex, and a few of our friends from the ecosystem from Confluent, Fivetran, and Puppygraph, we have released an Iceberg book. And I can definitely vouch this will be super useful for you. Yeah, this is the actually marketing part of the talk. Okay. Yeah. So far, it was there was no marketing. Okay. It was purely Iceberg talk. So, but yeah, this is the disclaimer, the marketing piece. Please download, connect to us. Would love to hear your feedback. Okay, thank you.
Any questions? Yeah. Hands up if we got a question. Yeah. Questions? Yes. Okay. I'm coming around with the mic.
Yeah. Okay. We need one.
Hey. Thank you very much for the presentation. I had a question about the highly availability part of the catalog. So if there's thousands of nodes, it's quite interesting how you guys would, I guess, have the catalog sync what's happening. So how do you guys spread out the updates? Is it eventually consistent? What's the delay to get to all the catalogs?
Yeah. So basically, underlying implementation is built on top of what MinIO's object model. And so MinIO is strongly consistent for objects. So basically, if once you write a put object to MinIO, even if you have a 1,000 node deployment, if the system gives you back 200 OK, which means it's consistent now. You can consistently read it across any of the nodes. The system, by default, the distributed system, MinIO AIStor, gives you that guarantee on any objects that you write into the system. There's never a case wherein the system returns 200 OK and some of the nodes you're not able to read the data from. So underlying implementation, since we don't bank on any index or any kind of data store or a database, it's natively baked directly into MinIO. So a lot of the metadata that the catalog actually needs, we have actually stored fundamentally as tiny objects. So, and those objects naturally now inherit all the guarantees whenever give it for any object in the inside the system. Yeah. Yeah.
Cool. Any other questions? Going once, going twice. And another big round of applause for Brenna and Karthik of MinIO.